Hello everyone, this is Nandi from MIDAS IT, and on behalf of MIDAS, I welcome you all to today's session on comprehensive concrete bridge design in MIDAS Civil. Now, there have been several sessions before in which we have demonstrated how user-friendly the GUI of the software is and how quickly the models could be generated using the wizard. So, in today's session, we'll mainly be focusing on the results and the design process in MIDAS Civil. So, these are the contents of today's presentation. So we'll have a look at the result extraction, then a brief about PSC design and rating because there have been several sessions on this before, then design of beam and column as well as checking for the same, then design and checking for plates. So recently we have come up with AASHTO plate designs. This can be used for slabs or your abutments, plate abutments. So we'll be going for a demonstration on that. Then how tile could be checked using the MIDAS package. And finally, the design of the pile cap. So in today's session, we won't be going much for the presentation, but we'll directly start with the software demonstration. So the first model that we'll be taking up is the PSC Composite Bridge. So it has already been generated before, it has been analyzed, and now we'll just have a look at the results. So into the results, first comes the load combination. So the good thing over here is the load combinations have to be generated in post-processing. So these can be edited without the need of redoing the analysis. These can be auto-generated. So you can just click on auto generation and basically our type is concrete. So whether you want to consider static load cases only or construction stages only or static plus construction stage, then that can be done. Then what load factors to be considered, maximum, minimum, or both. So that can be done for all the load cases. And now since this is a long dialog box, we have a small minimize button. So you can do that and your dialog box will shorten and just click OK. So all these load combinations would be generated. The results for that would be instantaneously available. So you can check the results. Now you can do this in any stage. So your first stage wherein only your pairs and pair cap is there. Then the next stage, girders only. Then the wet concrete is placed that you can see from the tree menu. Then the slab is activated and the SIDL is placed, and finally the long-term stage. Okay, so you can check all of this and you can check result at any state. So if I say stage 2, for example, if I want to check the deformed shapes, so I can check on legend and deform. So the advantage over here is you can easily gauge what is happening. So from here we can easily say that it has been overstressed because the girders are deflecting in upward direction. So you can check for individual load cases or you can check for the total. And this works at any stage. Similarly, you can check the beam diagrams. So generally we don't that in deformed state and look for the summation. Okay, so you can view the legend like this, or you can change it to fixed, and you can change the unit at any time. Okay, the results should be instantly updated. You can move on to different stages, and these are the results. Okay, similarly, you can even check the reactions at any state. So the reactions at each location, okay, for the summation, for your wearing surface, all of these could be obtained. Then if you want to check those in post CS, so here you will be getting the results for the moving loads as well as all the combinations that you have made. So you can go to any load combination and for that you will be getting it. Now, whenever there is a moving load, generally there is a need that engineers might need to know certain vehicle position which is causing the particular reaction. So in this case, if you would like to know which vehicle position is causing this reaction over here, so I can use the moving load tracer feature. So I'll go to reactions. I can just click here, yeah, and I can select the relevant moving load case and apply. So this is the vehicle position. As you can see, only this part of the bridge is loaded. So if you want to view the load values, you can do that, or you could just uncheck it to get an idea of the UDL and where the vehicles have been placed. Okay, so this is the moving load tracer. If you want to convert it into a static load, you can click on this write to file, and basically this would generate a text file. Now this text file could basically be copied and pasted. So this complete content could be copied, and you could go to tools, MCT command shell, just paste it here and click run. So this would generate a static load case for this particular vehicle. Now, if you want to add braking loads, or in case of a curved bridge, if you want to add your centrifugal forces, then that can be done based on this vehicle position. Okay, back to results. Any results, say you have started viewing the beam diagrams, okay, for any combination. If you want to view this in form of table, you could either click over here, or you can go to result tables, beam and forces. So I'll just click over here. Okay, so you can enter the element number over here, the load case for which you want the result, say these three, and on which part. So just click OK, and in the units that you have selected, the entire table would be generated. And as you know, this is completely Excel compatible. So you could directly export it to Excel or copy a certain part of it and paste it in Excel. Okay. Now let's move on to design. So under PSC, you could select AASHTO, then the parameters. So you need to select what output you are interested in, the type of tendons, the exposure factor, and other conditions. So in case of a PSC composite structure, it would be a non-segmental structure, and the exposure condition or the corrosion condition is mild. Then you select the material, so the grade of your concrete girder, the rebar for that. Similarly, grade of material for your slab and rebar for that. Now, for a bridge with these many girder elements, so you can say around 100 girder elements, there would be two sections, I and J. So overall, there would be 200 locations where you would be getting a design. So if you try to generate this complete sheet, it would be too much time consuming, and the generated sheet also would be too large. It won't be feasible to go for the complete check. So you need to select certain critical positions for which you need to go for design and Excel output. Okay, so in this case, I'll just click on design position and I'll just switch back to the original view. So you can select the elements for which you want the design at I end or J end and click apply. So in this case, I had done it for all the 10th point location of the fourth girder. So I could just quickly select those like this. And all the elements are selected. Just click I and apply. Similarly, for output positions, they repeat the same process. The PSC segment assignment would be useful for a box girder bridge, wherein multiple elements could be a part of the same segment. Then the load cases. So since we have generated the load combinations, the service limit 1 and service limit 3 would be taken automatically when these are auto generated. Otherwise, you could add these manually. Then the interface shear. So you need to input the bolt diameter, the bolt strength, spacing, how is the surface. So we have already done that. And once these are done, you can click on perform design. Okay, but it's already done for this particular model. So you can go to result tables. You can check the stresses at construction stage for your pre-stressing tendons at service stage. The principal stresses are available only for box girders, not for composite girder sections. You can check the crack widths, flexural strength, shear strength, and combined shear and torsion strength. Okay, so I'll just go for the service load demonstration. So again, you can select which elements, which part. So I'll just select the I part. Okay, so the stress is at top, bottom, then the four corners. What is the maximum stress and what is allowable? So everything is fine over here, so it's all okay. Similar tables are obtained. If you want the complete thing in Excel, you could click on Generate Report, and a comprehensive Excel report would be generated for all the sections which had been selected for output. So you can even get the generalized table. So like your stress output at construction stage. So as you can see, certain elements over here are failing that. So allowable stress was 2.4, but the acting stress was 2.44. So you could get a summary from over here for all the required elements. Similarly, at your service stage, so certain elements are again failing, so it can be checked over here. Principal stresses, as I said, would be available for box sections. So it's even mentioned at the top here. Then the tendon stresses. So for all your elements, all the tendons which are there, you can get a brief summary over here. Then your each section. So as you can see, number of Excel sheets have been generated, and these are just for 10 elements. Okay, so your section properties, material properties, location for the strengths, and sorry, their strength, yield strength, and ultimate strength. Similarly, for a reinforcement, which is not there in this case, and it wasn't defined visibly. Then the stresses in the tendons and the flexural design. So at all the locations, the code clause reference has been mentioned, as you can see over here, and the parameters which would be used further in design. So these are your tendon stresses and the concrete stress. So the flexural resistance is calculated, and if it's okay, it will show as okay, and we'll see if somewhere it's not good. So even the checks, whether it's required or not, it could be seen in the report. Okay, so positive, negative, then shear design. Okay, the spacing of the reinforcement. So everything is checked. Your interface shear. So it's way more than what is required. So that's still okay. Because for PSC design, it's basically a check. So based on what we have provided, the software will mention whether the design requirements are being satisfied or not. Okay, so you can see all the codal references. I'm looking for something that's failing. Oh yeah, over here. So for torsion, basically I had not provided anything. So as you can see, it's all 0 and ng. Okay, so this is the way in which the report would be obtained. All the formulations and everything would be available. So all your sections. So you can see for only the 10-point location of certain sections, it's such a huge file for checking. Now, if it's done for all the sections in the bridge, it would be way too big. Okay. Now let's move on to rating. So just how we did for design, we need to define the parameters for rating. So you can go to rating tab. If required, you can define certain common parameters like the definition of frame in case if required, whether it is braced, unbraced, and how to calculate the effective length factor. So that can be done. In this case, we'll just concentrate over here. So it's a PSC bridge. So the rating parameters. So you can define for strength limit state, service limit state, the legal loads if those are there, and your diagnostics test if you have those available with you. Then the group setting. So you can select for which particular group of elements and at what location you want to go for rating. You can even change the condition factor from over here. Rating material just as we did for PSC material. Then the rating case. So all the load cases which you have defined would be available over here under the rating case for selection. So under DC, dead load of components, you can select what all load cases you want to put in. So over here, you will get the construction stage loads if you have defined the construction stages, or you'll get the static loads only if there are no construction stage. So if you have the construction stages, it is recommended to go for the construction stage loads and not the static loads. Similarly, the loads for your wearing force, if you have a defined temperature, your secondary load cases, permanent load case, and certain other user defined case if you have. Then the live load rating. So for your primary and adjacent vehicle, for service, it's all one, but for strength, you can see those as different. If you have an adjacent vehicle, you can put the factor for that, or you can put it as 0. So service case, similarly your strength case. So as you can see, maximum and minimum as well as the factors have changed. So you need to define the rating cases. Then the reinforcement information. If you have already defined it before, it's not required to do that again. Diagnostic test result. And then you just need to click on perform rating design. So you can check the result tables there, or in this case, I have already performed the design and I already have the report with me. So you can get this kind of a PSC rating report for your strength limit and service limit. Similarly, you can obtain it in detail for each selected output position, your rating factor for strength, what is the capacity, demand, live load demand. So as you know, it's a very simple calculation. Capacity minus demand, dead load demand by live load demand. So that would give you this particular rating factor. Similarly, in strain, you get these for shear. Similarly, for stresses in service case, for your girder as well as for your slab, and this is obtained for all the required element positions. Okay, so that's it for PSC. Now we'll move on to slab bridge. And yeah, actually the design process for any PSC element, it remains the same. So even if it is your PSC peer cap, then also the process to be followed would be the same. The output that you would get would also be similar to that of what we have just seen for the PSC bridge. Now coming to the slab bridge. So this is a skewed slab bridge. We'll just have a look at the support conditions. So you can click on this button over here, boundary, and I'll just activate all. Okay, so this is the support condition. This is my bridge. Okay. Now, when we see the plate results, so we are generally interested in seeing how the bending or the forces are going to behave along the plate. We need the force per meter width. So that you can obtain from results, forces, plate forces and moment. Again, this can be for load combination or any particular case. So I'll just keep that load for now. Now this MXX. That is basically the bending moment along the local x-axis of the plate element in this case. So now where is this local x? So I'll just go to display, element and local axis. Okay, so this mxx is actually along the longitudinal direction. So that's the moment I'm interested in right now. So mxx, I'll go for average nodal. Okay, and if I just click apply, legend. So this is what I get, right? It's okay, but still it doesn't give that bending moment diagram. So for that, you can click on the cutting diagram and you can click on the 2 points along which you would like to see the bending moment profile. So do that and I'll just check it and apply. So with that done, this is the kind of bending moment profile that we see. So this is as expected. Right near the support, it is peaking, and in the mid, it is sagging. So the bending moment behavior for dead load is exactly as we want. If we want to change the values, like over here, I had kept it minimum and maximum only. So if I uncheck that and click apply, so I'll get it at all the locations. It gets a bit hodgepodge, but it gives you a better idea. And this is in kips inch per inch. So if you want to change that to kips feet, so this is the bending moment in kips feet per feet. And this could be further used for design. Besides that, the things that we had discussed for the PSC result interpretation, those remain the same. In this case, there was a settlement load which was applied. So MIDAS has recently introduced a feature for concurrent forces in case of settlement. So if you want to activate that, you could go to analysis, settlement, and concurrent forces. So you need to activate this. And if you want to see the results for that, that can only be done in results table. So you could go to results, result table, plate, forces and stresses. You could select any load case required. CCLCB1 all. Okay, so for all the plates at all the node locations and center locations, the results would be obtained. Again, you could change the unit to kips inch if required, or rather pound inch. Yeah, okay, this is fine. And if you want to see the concurrent forces, so in that case, so the concurrent forces would be available for the unit length. So you need to select the settlement cases. Let's just keep it center for now. So you'll get this result table. You can right click, view by max value icon, and you can select which should be the main component, and accordingly the other concurrent forces would be obtained. So MXX, okay, and it will create a new table result by max value. So when the MXX is maximum, so at that time, what are the other concurrent forces that you can obtain for settlement now? Okay, so that's it about result interpretation. Now let's move on to the design. So first off, we'll go for RC design. So I'll come back to this model and we'll design the pier and the pier cap for this. So I'll just activate that part to make it easy for me. Activate. Oops. So I'll just activate this much. Okay, so this is the pier and the pier cap. Now the design of the beam elements, like in this case, if you see, the beam is divided in between. So for finite element software, each element is treated individually. But if you want to treat a group of elements as a single element, then under common parameter, you need to go for member assignment. And I will just delete this to show you how it can be done. Okay, so we select the relevant beam element. Okay, we'll add. It needs to be automatic, and I'll just say apply. So basically, this entire part would be treated as a single beam for design. Similarly, this part would be treated as cantilever, and so on. So this is how it can be judged. Okay. Also, if you need, you could define the frame, so braced or unbraced, and for effective length calculations, and your load combination type. Okay. So let's move on to design. So just like before, we need to select the standard, the reduction factors. So you could keep these by code, or you could change it if you want. Then the rebar ratio. Then if you want to scale up, you could go for the scale up factors for the columns. Then the beam section for design. So you could click on that. There are two things. One, you can give details for design, or other, you could give the complete reinforcement detail and you could check it. So in this case, what I have done was, for the pier cap, I have given data for design. So I'm using number 4 bar, and the cover is 2 inch, and the number of legs for the stirrups is 10. Then I could just go to concrete code design, beam design. All it requires is the stirrup input. You can see in the message window that the design is in progress, and that's it, it's done. So I have selected only these elements. So for only those elements, the design would be done. So overall, it's all passing. You can view by section, and you can view the graphic report. Sorry, you need to select, and you can view the graphic report over here. So what is the reinforcement at I end, mid, and J end? The ratios. So at mid, it's as good as 1 for negative moment, for your positive moment, and your shear capacity and the torsion capacity. It's not there in this case. If you want to see the detail, you could click on member, select any individual member, select the location for output. So if you want the output at mid, so you could select that, click on detail, and a comprehensive text file would be generated. So it would have all the details, all your load combinations which have been considered with their factors, and what are your material properties, your section properties, rebar properties. Then you can see the negative bending capacity. So how it's proceeding. The moment resisting capacity ratio, it's 0.98. And maximum and minimum reinforcement, obviously the reinforcement check. So you can see over here how it is optimizing your reinforcement. Okay, so it tries to keep the ratio around 0.95, 975, sorry. Okay. Similarly, it checks for your shear capacity and the torsion capacity. So it's not required in this case. So this is the detailed report. You can save it or you could simply discard it. Okay, so this is the beam design. Now let us proceed to beam checking. So beam section data for checking. So again, for pier cap, I'm doing it. So I can define the reinforcement at I end, mid, and J end. Okay, so at I end, I have again considered number 4 bar for stirrup, spacing of 4 inch, 10 legs, and the angle is 90 degree. the two layers, so 20 bars of number 8 and 2 each cover for top and bottom. In the mid, I've increased the spacing for stirrup. Again, at the support, I'm reducing it. So with that detail, now let us go for checking. So concrete code check, beam check. Again, only the beam is selected. And based on our input, it's terribly failing. So it's failing in shear. Over here, it's failing in shear plus more. And again, near the support, it's failing in shear. So let's see which member is failing. So number 31. So I will just click on connect model view. And if I select 31, so I can see my cantilever part is failing. So now only this much part is selected, but in fact, the design is for the complete cantilever. Okay, so you can click on graphic just as before. So over here, you might see that things seem fine. It's not an issue. Oh yeah, over here also the shear capacity is less. So once you see that, what you can do is you could reduce the spacing, and again, the check could be performed and it should be safe. If you go to detail, now here it's for IN. So let's see, these things we had already checked before. Okay, this is fine. Torsion check not required. Oh, correct check not required. Let me see which part is failing. Oh, so I end is actually completely fine. So there is nothing failing over here. If I select mid and if I click on detail again, so this will give us a clear idea. So moment was failing and shear. So this is fine. And you can see over here, the shear resisted by steel is less than the ultimate acting and the concrete capacity. Okay, so it's 778, 5 ES is 700, and VU is 883, while 5 EC is 124. So overall being resisted is 824, but the acting is 883. So the complete details are provided in this report. Similarly, you can go for column check. So you could go to concrete, column section data for checking. Again, the rebars have been provided for checking. So design, code check, column checking. Again, it's failing, so you could check it in graphic and detail. Okay, so shear capacity is failing, and you can even see the PM curve for it. Okay, so this is fine. You could check at different angles as well. Okay, so that's it for concrete pier and pier cap design. Now let us move on to the new feature, which is plate. Okay, so for plate design, we'll consider this particular box culvert model. So I'll just select a part of it for designing. Basically, if you want to design plates in MIDAS Civil, you'll have to create domains and subdomains. So under nodes and element, you can click define domain. We'll select all the plates and we'll give it design domain and give it a name, add. And now we have to add the subdomain. So here, let me first of all try designing the center of the box. So give it name BC, and rebar direction I'll keep it along UCS for now. Here you need to define what is the member type. So if you are designing the top slab, then that would be a plate beam. If you are designing the side walls, then that would be a plate column. So in this case, since I want to design for center of the box, it would be a plate beam. So now we'll select a short subdomain for which we want to design. So let us say we are selecting these plates, and I say add. Yeah. Similarly, I'll add a domain for plate column. So I'll select this plate with plate column, side wall center, and I'll click add. Okay, so I have added the center of box and uh, center of wall. So I have defined the domains and the subdomain, given the direction of the reinforcement. Now when you define the domains, so you'll have to reanalyze. So we'll just quickly reanalyze the structure. Once this is done, we can go for the load combinations. So results load combinations, and those have already been defined. So we could move on to design. So over here, now, just like we did for simple beam elements and column elements, here we have to go for plate elements. So column section data for design, plate beam data for design. Click on that. So you need to select the domain and the subdomain. So BC, I have kept the same subdomain. Direction 1 is the main rebar direction. If you want to provide stirrup, you can do that. I'll just change the units to inch, and I'm providing 2-inch clear cover. So that's all. The cover data is required for that. Then the rebar input for plate beam. So in case you want to go for checking, so in that case you have to give this. So again, I'll just give rebar center to center. So I'll keep it 6 inch, and I can select the number. So number 10 and cover. Similarly 6 inch, 10 and cover, and add. Okay. Oh, sorry. The size is not proper. Forgot the distribution bar. So again, center to center 6 and size 4, same 6 and 4. Okay, so this has been added, main bar and the distribution bar. So it's always handy to keep a view on the message window. Close it, and just like before, you could go for concrete code design first of all. So plate beam design. So like before, you'll be getting the table. You can check on that. Click on graphic for the graphic output. So what is the size and what is the, so since it's center, the positive reinforcement is being checked, and as you can see, it's close to 1. Sorry, design. And if you want to check it, you go to RC design, concrete code check, plate beam check. Oh, sorry, improper data input. Yeah, so what we had done was we had just defined the reinforcement arrangement, but we had not assigned it to the slab for checking. So we had done this part, right? But we need to do the one after that as well. So beam data for checking. So subdomain PC, rebar, and add. And then you could go for plate check. And again, you can get the graphic report. So in which you can see the rebar arrangement, the spacing, and it's way over safe. And you can get the detailed report for that as well. So the load cases, the combination which is critical, the reinforcement arrangement, the positive bending capacity, similarly your negative bending capacity, it's non-existent in this case, and the check for shear. So shear reinforcement is not required, as you can see. Crack check, so that is also fine. And if you have assigned shrinkage and temperature loads, then for that also the check is being performed. Okay, so in the same fashion, you can go for concrete core check, column check, and we also have a document available for this. So for a box culvert, so this is just the load calculations, and then the load combinations which have been taken, how the domains or the subdomains can be defined, the reinforcement arrangement, and when you check it, so what all you get. So this is a comprehensive guide on how the plate design feature can be used, what are the code clauses being checked. One thing that I forgot to mention over here is when you go for column design, so the axial contribution is not considered when going for design, but when you go for checking, so this axial contribution is also considered. Okay, yeah, so I think it's mentioned over here. So you can see the report is quite detailed actually. Okay, so we would share this with you guys after the presentation. So now we'll be going for pile design. So if you want to go for pile design, so your stresses in your reinforcement and your concrete stresses, so for that we have a specialized tool which is a general section designer. So you could just click on that, and if this module is available with you, then you could link it with your MIDAS civil file. So you could just click on this button over here, and you could link it to the relevant file. Okay, so now you can select certain element. So if I select one element over here, then that would be available for me over here, and I could simply import. So if I am importing after performing the analysis, then the software will ask me what all load combinations I would like to import and which part, that is I end or J end, which end of the section I want to import. You could select even the in between section. So let us import I end for say. Okay, so I'll just delete the earlier section. And this is the section, and these are the load combinations. So you could check your concrete property. So the material property, yeah, I'll change the units to kips and inch. And just modify this particular concrete property. Okay, now to assign the reinforcement, it's very simple. Just select the shape, and I would like to give it along the perimeter. So right click on perimeter and add. The standard would be ASTM, say grade 50. Okay, say number 10 bar, say 3 inches. Now, and I just select the shape, it is unselected, and apply. We want to provide it in two layers and even say different diameters, so I can do that as well. Okay, so 4.5. Okay, so this is how you can assign the reinforcement. Then under option design code, you can select AASHTO LRFD. You could modify the parameters if I change this to 85. So you can do that. And that's it. Now all you need to do is perform the analysis. Yeah, as for the load combination, so as you can see, we have already imported these from the already analyzed file. Then you could perform the analysis. If required, you could save it. Okay, so you can perform the analysis and it would be done. I already have an analyzed file with me as well, so I'll just open that. So as you can see, it's similar, but I had imported the envelope cases. So those load combinations basically have moments as well, so it will give us a better idea. So now I'll just perform the analysis for this one. And just like that, the complete thing would be listed out. You'd get your interaction curves, moment interaction curves, and you'll be getting 3D curve. So here you can clearly check what are the conditions. Okay, so if I change the load combination, so accordingly, my location of the point of application would be changing. Okay. Similarly, you can check the stress contour. So let me just select. Yeah. So under elastic state, what's happening? Somehow, uh, yeah. Okay. So you can see it in alignment to the neutral axis as well. So if you want it straight, you can do that, or you could check in accordance to the actual section. You could check the correct elastic conditions. So if you want to ignore the concrete in tension, so you can do that. And you can check the ultimate state. You can check the stresses in your reinforcement or directly in your concrete. So for 4KSI, is I had reduced the compression component. So you can see the allowable capacity is 3.4. So you can check the stress contours. You can check the forces as well. So this is better in neutral axis. So you can click at any location and you can see what is the stress and what reinforcement might be contributing. Okay, so that you can check from over here. Now this is just a graphical view, but if you want to view the table, you can click on report and you can obtain the report for ultimate state, cracked elastic or elastic. So I'll again show you the reports which I have just generated. So this is the report for the elastic state. So it states the property, section property, material properties, and the load combinations. And you can check the stresses over here. So stress in concrete, tensile stress in concrete, and tensile stress in rebar. And these are the rebar forces and stresses at all these different locations. So the origin is at the center, and Y is the horizontal one and Z is the vertical one. So you could trace each rebar from over here and you can get the forces and stresses acting in that particular rebar. Similarly, you get the report for the ultimate state. So all these rebars are under complete tension and all these rebars are under complete, these are under complete compression and these are under complete tension. Okay, so you can see these are multiple bars. Now for pile cap design, we have another package actually. So in this particular package, you could design in accordance to ACI. Okay, so it's quite simple. You could select once you start a new file. So you could select footing design. Then under design options, you could select which standard you would like to follow. You could select the rebar options. So over here, basically you can give what are the spacings that you want to consider for moment and shear. So this software is basically an iterative software to optimize your design. So you could select isolated footing, and in that material data, the acting load data, and whether to include the self weight, what is the surcharge load. So based on the input over here, your image would also be updated instantaneously, so it would give you a clear idea of what you are designing. Then whether you want to design mat footing or pile footing, so pile cap in this case, what should be the depth of the footing? So 50, you could change this. Then how is your column? So I have kept 36-inch 3 feet diameter, and the location, so it's basically an eccentric column to the footing. Okay, so you could give these input. Then you could simply click on design. So it will design and shows that it is failing in shear. So we could increase and you can again click on design and now it's passing. You could easily change the pile layout. So if I change the number of piles, say 9, 10, so as you can see, the pile locations and the arrangement is changing. And I could click on design again and it's being carried out. Again, it's failing in two-way shear. It is better. So this is fine. If you have a specific rebar arrangement for which you would like to check, so if I change this to 6 and if I click on check instead of design, so it will show me that the rebar provided is not sufficient. Okay, even in this, you could generate the complete report. The report could be of multiple type. It could be detailed or summary. So if you click on summary, sorry for that. So basically, if you click on summary, you can get a summary of that. And if you click on detail, you'll get a detailed report just like this one. Okay, so again, it lists out the properties, the acting loads, the dimension, the load in each pile, and whether it is okay or not okay. Okay, so that's it about today's demonstration. So if you want to check out other detailed videos, you could visit our website northamerica.midasuser.com. And if you have any questions, you could write to those to us on global support at midasuser.com as well. Thank you.